So yesterday we have discussed about transistor and current component, right? So collector side, we are getting two component. One is due to the holes which are transferring from emitter, and another one is leakage current. So that is ICO. Okay. This ICO name is given because whenever you will take open circuit of emitter base junction, then you are getting that current, only leakage current. So collector current when emitter base is open circuit, that's why O is written open. So ICO deals with leakage current. Now if I consider leakage current is not present, then what I am getting, IC will be equals to only this one. IC equals to the holes which are moving from emitter, that will get, yes or no? So what is IC? You see this IC equals to what? IC due to hole plus ICO. If ICO will be not there, then IC will be equals to only the holes which are traveling from emitter to collector. Yes or no? You see this equation. Yesterday I have given all these equations. IC equals to this plus this. If ICO will be not there, then IC equals to only ICP. Now tell me, IC, suppose I'm sending 100 holes from the emitter and 98 holes are reaching here at the collector, then can I say I'm getting a fraction of holes at the collector which is sent by the emitter? And I can write IC equals to some fraction of IE. So that fraction less than 1. That's why when I'm sending 100 holes, I'm reaching here at the collector, sorry, emitter, I'm sending 100 holes, I'm getting 98 holes. If it is equals to 1, then it is 1 means IC equals to IE, which is not true because during the base region some recombination happens and we are not getting the same number of holes which are sent through the emitter. So this thing can be written as IC equals to alpha IE. IC equals to alpha IE, where alpha is less than 1. Alpha is less than 1. So any doubt from this equation and current component you ask me? Which component you have not understood? Yesterday we have discussed emitter current, base current, collector current. Emitter current is due to hole and electron. Then base current is due to IB1, IB2 minus IB3, and collector current is due to IC due to hole plus leakage current. And entirely total IE equals to IB plus IC, and this IC equals to alpha I, just now I explained. Any doubt from this point? Because a lot of question will get here, numerical question, like suppose IE will be given, IC will be given, you have to find out IB, or IC, IB will be given, you have to find out IE. If IE will be given, alpha will be given, you have to find out IE. Leakage current will be given, IC will be given, you can find out the component which is sent by the emitter. So using this equation, lot of question can be framed. Here in this diagram, only in PPT you will find the diagram, explanation is not there, so you have to explain in your own language. Okay, what is IE due to a hole, what is IE due to electron, what is ICP, what is ICO, what is ICO due to hole, ICO due to electron, IB1, IB2, IB3, everything you have to explain in your own language. Okay, so that's why you need to understand it. Now we'll see the name transistor, why it is given. If you consider the transistor, what we have discussed, the emitter base junction and collector base junction. So emitter base junction is which type of biased? Emitter base junction which type of biased?
Forward.
Collector base junction.
Reverse.
So in forward bias, depletion region is wider or narrow?
Narrow.
Reverse bias?
Wider.
Wider. So you see here, whenever we are sending current is moving from forward bias region to reverse bias region. So if depletion region is narrow, that means we'll find less resistance, and reverse bias wider depletion region means it will offer high resistance. So actually current is moving from low resistance path to high resistance path. Okay, so that's why you can see the transfer and resistor, these two terms are given. Transfer means current is transferring from low resistance path to high resistance path. So current transfer and resistor, using these two terms, some part of the transfer and some part of resistor is taken to combine to get the term transistor. Okay, so you can see here in red color I have marked transfer plus resistor. So trans from transfer, resistor from resistor, so combiningly it is called as transistor, and here the region is written. Okay, now different configuration of transistors are there. So as the BJT have three terminals, there are basically three positive possible ways to connect it within the electronic circuit. One terminal being common to both input and output. That means, suppose I'll take a transistor here and I'll give input and output, because transistor will be used for amplification purpose. So we have to give input, and according to the circuit condition we'll get the output. Now suppose this is my transistor and here I am amplifier used in amplifier. This is output. So inside amplifier some transistor is there. So this one is my input, this one is my output. Now inside the amplifier, how the transistor will be connected, whether it is connected in common base mode, common emitter mode, common collector mode, different configurations are there. So how you can identify? There are three configuration. Common base means CB mode or CB configuration, common emitter, that is CE, common collector, that is CC configuration. So you know, 3-terminal emitter, base and collector. So common terminal or common term is added to that to get different configurations. So what is the advantage and how we'll identify this configuration, we'll see. So here it is written one terminal is being common to both input and output. So let us try to understand this one. Suppose I will take a transistor like this, then yesterday also I have drawn like that. This is Pnp transistor, and I'm not connecting any voltage, resistance and all. Just I'm showing here input and output. This side I'm giving input, and here I'll take output. So input I'm giving from which terminal to which terminal? This is your emitter, this is your base, this is your collector. So input is between which terminal? Look at the figure and tell me.
The base and emitter.
Base and emitter. And output?
Collector and emitter.
So which terminal is common between input and output?
Emitter.
Emitter. So that's why it will called as common emitter configuration. CE means common, C for common, E for emitter. So common emitter configuration. Okay, or also you can say common emitter mode or configuration, anything you can take.
Sir?
Yes?
Sir, can you once again explain this?
As there are 3 terminal, I'm giving input and taking output. Right? We'll amplify the signal. So we have to give some signal. Then at the output, we have to see the output signal, how it is, whether it is amplified or not. So I'm giving input between this base terminal and emitter terminal. Okay. And taking the output between collector and emitter terminal. I have not connected voltage, source, resistance, all those things. I'm simply just try to focus here how the emitter terminal is common between input and output. Okay. For proper circuit, we have to connect resistor, voltage source, all those things. So if you look at this figure, between input and output, which terminal is common? See, between here I am giving input means I am giving between base and emitter. Here I am taking output between these 2 terminal. That means collector and emitter. So emitter terminal is common between input and output. Yes or no?
Yes, sir.
That's why it is called as common emitter configuration. So you see here, these 3 configuration are given. Now tell me 3 configuration, which one is which type of configuration? First one is
The common emitter.
common emitter. Intentionally I have not given the terminal name and current because you have to identify. Okay. Second, middle one,
Common collector.
common collector. Third one,
Common
Common
base.
base.
Common base.
one base. Now we have just now understood that how we can arrange or identify different configuration. So what is there? Only the orientation of transistor such that the terminal which is common, we are saying that type of configuration. Now, why it is used? Why this orientation and common emitter, common base and common configuration, collector configurations are there? Generally, in further classes we'll understand. If you consider common base configuration, then it will give you voltage gain, but it will not give any current gain. That means if I'm giving voltage signal as input, it will be amplified, but if I give current signal, it will not amplify. Okay. Now if you go for common collector, then it has current gain. That means if because any signal can be represented as I equals to Im sine omega t. That means it is a current signal or voltage signal. I equals to Im sine omega t, current or voltage signal?
Sir, current.
Current.
If I want to write voltage signal, then V equals to Vm sine omega t. So these 2 type of signal you can represent. That means whatever real time signal or like I'm talking means my mechanical signal or voice signal will be converted to the transducer, and this signal is given to the amplifier. So current or voltage signal will be given to amplifier and it will amplify that one. Okay, so if I take common collector, then it will have current gain. That means if I apply current signal, it will be amplified, but it will not amplify voltage signal. So if I specifically require to amplify voltage signal or current signal, I can use current common base, common collector. But common emitter is most preferred configuration because it will have voltage gain as well as current gain. Okay, it will have both voltage gain and current gain, as well as you can also amplify the power because P equals to V into I. So out of these three configuration, common emitter is most suitable and most preferred one. Now you understand how to make these configurations and why it is used. Now one by one we'll go for this configuration and related equations. So first we'll see common base configuration. So previous slide I have explained how to draw common base configuration without connecting resistor and voltage source. Now we'll do entire circuit. So for common base configuration, first what we'll do, first you draw the transistor such that base terminal at the bottom side, right? Then emitter, collector. So for simplicity, I'm taking Pnp transistor. I'm taking, this is my emitter, this is collector, this is base. Now what I'll do, I'll bias it. So emitter base junction should be forward biased and collector base junction should be reverse biased. So what type of transistor is this one? This is P, this is N, this is P. So forward bias means P side should be connected to higher potential, N side should be connected to lower potential. So what I'll do, I'll connect a resistor. Generally resistor will be connected directly. We cannot connect the voltage source because sudden change in voltage source may damage the transistor. So some resistor is connected. So that resistor I'll give as name RE because it is connected to emitter terminal. Then P side should be connected to higher potential, N side should be connected to lower potential. Okay, and I'm giving here the name as VEE. Okay, VEE, and the potential difference between emitter and base, I can use one voltmeter to measure, and this will be VEB. Okay, is it clear? You can use potentiometer or directly also you can write here like VEB between emitter and base. Okay. Now collector side. Collector side should be reverse biased. So P side should be connected to lower potential. So I'll connect first one resistor and I'll name as RC, then lower potential, then higher potential. This will be VCC, and the potential difference between collector and base I'll give as VBC. Then current, so this is your IE, this is your IB, this is outgoing current IC. So this is the way we'll draw the circuit diagram. Understood how to draw the circuit diagram? You can also ground it. So first orient the transistor such that which terminal is common. Then you bias the emitter base junction, collector base junction with some resistor. Then you name the current components and voltage. Any doubt? Now what is my output current? Output current means here I'll take the output. With respect to base, collector terminal is my output. With respect to base, emitter is the input. So what is my output current and what is my input current? Can anybody tell me? This side is output, this side is input. So what is my output current? What is my input current? आउटपुट साइड में क्या करंट है? What is the current in the output side? This is my output side. What current you are finding here?
Sir, IC.
IC. And at input side, what current you see?
IE.
IE. Okay. So output current by input current is equals to IC by IE. So output by input we called gain. Gain means output by input. So output is IC, input is IE. So this gain is called as current amplification factor alpha. Current amplification factor alpha. Okay. And if I cross multiply, what I'll get? What I'll get? IC equals to alpha I. Yes or no?
Yes, sir.
Yes, sir.
So this is the alpha what I just starting of the class explained. This alpha must be less than 1 because IC is my output current, IE is the input current. So I am getting some fraction of input current at the output. Suppose I am sending here 100 holes, I am reaching 95 to 99% of hole. So due to that, I am getting less current at the output. So this alpha is called as current amplification factor, and generally the alpha range between 0.96 to 0.995. So alpha ranges between 0.96 to 0.995. That means 96 to 99.5% of holes which is sent by the emitter that should reach at the collector. That is my objective. Clear?
Yes, sir.
Now let us little bit expand this equation. So I want to find out if you observe here what I have explained. This is my output, this is my input. So I have expressed the equation output in terms of input. Okay, I see in terms of some factor into input. Now in terms of IB I want to find. So we have got this one, IC equals to alpha I. Now we know this basic equation, I equals to IC plus IB. And in place of IC, if I replace alpha IE, then what I'll get? We know IC equals to IE equals to IC plus IB. So IE equals to, using this equation, alpha IE plus IB. Okay. Now take IE one side. So IE minus alpha IE equals to IB. So that implies IB equals to 1 minus alpha into IE. So what I have done here, input current is my IE and this is your base current. Okay, I have expressed base current in terms of input current. That means if you know input current, you can find output current, that is IC, as well as you can find IB, that is base current. Three components are there: IE, IC, and IE. So if you know input current IE, you can find IC, output current, as well as base current IB. Okay. So till now, whatever I have explained, that is not consider the leakage current, the component which is due to reverse bias of collector base junction, what we have discussed here. This component we have not included. Okay, only this majority component we have included. So if I include this leakage current, then what I'll get? See here, IC. Let me take another color. IC equals to alpha IE. Right? You go to the figure again. See here, IC current is, if I apply KCL at this point, this current, this current, this current, two are incoming current, one is outgoing current. So outgoing current IC equals to ICP plus ICO. Okay.
Yes, sir.
So that same thing I am considering here. So IC, that means output current, is some fraction of input current, that is alpha IE plus leakage current. So leakage current is ICO, that means collector current when emitter base is open circuited, ICO for all configuration. But for common base, it is denoted as ICBO. For common emitter, it is denoted as ICEO. For common collector, it is denoted as ICCO. Okay, for different configuration, leakage current name is changed, to identify common base, that is ICBO. For common emitter, ICEO. For common collector, ICCO. So here, in place of ICO, I'll write ICBO because this is common base configuration, right? So this is your common base configuration. So that's why I'm writing here ICBO. Now let us solve here. Alpha I'll keep it, and IE, you know, IC plus IB. So IC plus IB plus ICBO, that is equals to IC. Now you open it and take one side IC. So alpha IC plus alpha IB plus IC BO equals to IC. And if I take it one side, so this is your IC minus alpha IC equals to alpha IB plus ICBO. Then you take common 1 minus alpha, then divide in the right hand side, right? What will get? IC equals to alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into ICBO. Okay. So if leakage current will be not given, then directly you can find IC equals to alpha I, like this one only, IC equals to alpha I. If leakage current will be given, then you have to add ICBO. Similarly, here also, if you know IB and leakage current, you can find out IC. So this is for common base configuration. Okay, here it is written ICO equals to ICBO for CB configuration. Now we'll go for common emitter configuration. So if you draw common emitter configuration, first orient the transistor such that emitter terminal at the bottom side. So again I am taking PNP transistor. So this is your emitter bottom side, this is collector, this is your base. Now this is P, this is N, this is P. So emitter base junction, collector base junction should be reverse biased, emitter base junction should be forward biased. So here in the previous case, you can see directly you have got this junction. This is your emitter base junction and this is your collector base junction. So I have applied directly, the voltage is connected. But in this case, you will not find direct connection. That means this is your emitter base junction, okay. But collector base junction is this one. Okay, so let us see how I'll connect the voltage source so that you will understand. Emitter base junction should be forward bias or reverse bias?
Forward biased.
So I'll connect a resistor here. It is connected to base. So I'll name it RB. Then what I'll connect, positive voltage or negative voltage? Tell me. N side should be lower potential. P side should be higher potential. Is it correct? They'll name it VBB. Okay. Now collector base junction is not directly connected, or the junction is not there because I cannot connect collector and base. I have to take collector and emitter. In between that, I have to take the output signal or output voltage. So I should connect here the voltage, not between collector and base. So how I'll do? What I'll do? I'll connect one resistor here across the collector and name as RC. Then here and here I'll connect one voltage. So what I'll do, I'll connect this voltage, that means collector to lower potential, emitter to higher potential. And name as PCC. Now between these two, this is VEB forward biased, and between this VCE, or you can also write VEC because directly it is seen EC. VCE and VEC, why I am writing VCE means what? VC minus VE, potential at collector minus potential at emitter, and VEC means potential at emitter minus potential at collector. So here you can see emitter is positive, collector is negative. So that's why emitter is higher potential, collector at lower potential. So it should be VEC. Okay. Now let us test it, because this one is not directly you can understand or visualize that which one is higher, which one is lower, whether collector base junction is forward bias or reverse bias. Both are connected to negative voltage. So what I'll do, let us take an example here. Let us take this is 5 volt or minus 5 volt, because with respect to ground it is minus 5, and here 7. Okay, so minus 5 and minus 7. So consider this emitter base junction. If you consider emitter base junction, this is directly, you can understand this is forward biased, because N side is connected lower potential, P side is connected to higher potential. So minus 5 means it is forward biased. What about collector base junction? Collector base junction means this is your collector potential, this is your base potential. Okay, so VC and VB. So VC minus VB is your VCB. So what is my assumption? P side should have lower potential and N side should have higher potential. Then only the collector base junction should be reverse biased. Yes or no?
Yes, sir.
If I take diode, let us take this diode. Okay, this is P, this is N. So here N means this one, P means this one. So I want to reverse bias this one. So I am connecting here. N side what is connected? -5. P side what is connected? -7. Now tell me, it is reverse biased or forward biased?
Reverse.
-5 is more than -7. So that's why N side is higher potential, P side with lower potential. So this junction is reverse biased. Okay. So comparative statement you can take. So both are negative voltage which is connected to base emitter and collector emitter. So that's why comparatively you can say depend on that we have to bias the voltage. Okay. So don't confuse that both are negative, how it is reverse biased. So it is a comparative statement. Now once you connect, then you represent the current. So collector current, here emitter current is entering. IE entering means IB will outgoing and IC will be outgoing. So here I'll take output and here I'll take input. So what is my output current and what is my input current? Output side, what is my current?
IC.
IC. Input side, what is my current?
IB.
IB. The direction is opposite, but we'll take magnitude. So IB. So IC by IB is your gain or amplification factor. So here it is called as current, same like previous case current amplification factor. Here this is also current amplification factor beta for CE configuration. Alpha is for CB, beta is for CE. Okay. So if I cross multiply, what I'll get? IC equals to beta IB. Yes or no? IC equals to beta IB. So alpha ranges between 0.96 to 0.995, but beta range is high. That means 25 to 300, even more than that you can get. So beta value is high. Okay. Now, if I compare the previous equation, this one, this is actually, you compare this one and this one, IC equals to beta IB, and if I compare only this part, what you will get? IC equals to some factor into IB. So from this comparison, what you can understand, beta is equals to how much? You only take this one. IC equals to some factor into IB. Here IC equals to some factor into IB. So this factor will be equal or not?
Yes, sir.
So beta equals to alpha by 1 minus alpha. We'll again derive that one, but for this one you can understand. Now if you consider leakage current, so IC equals to beta IB plus leakage current. So leakage current I'll write here ICEO. As I told you, for common emitter it is ICEO. Now we again compare IC equals to, here what we have got, alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into ICBO. Okay. Here we have derived in the previous case this one, this entire equation, IC equals to alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into ICBO. So here same thing I have written. Now you compare these two, what will get? This factor is same as this factor and this term is same as this term or not?
Yes, sir.
So what I can write, beta equals to alpha by 1 minus alpha and ICEO equals to 1 by 1 minus alpha ICBO. BU. So that's why if you put alpha is less than 1, then you will get beta high. And tell me, ICO will be higher or ICBO will be higher if alpha is less than 1 from this equation?
Sir, ICBO.
Hmm.
No, sir, ICEO.
ICEO, because in the denominator we will have 1 minus alpha. Okay. So
Yes, sir,
if
yes,
you
sir.
take 0.95, then it will be more than ICEO. So leakage current for common emitter configuration is more than common base configuration. Okay. Now we'll go for common collector. So common collector, you see here, common collector, the same way we'll draw. First we'll orient the transistor such that collector terminal at the bottom side. So this is your emitter, this is your collector, this is your base. Then base collector is directly we can see because this side will give input, this side will take output, so it is easily visible. So collector base junction should be reverse biased. So I'll connect one resistor here, give the name as RB. Then this is what type of transistor? This is P, this is N, this is P. Okay, so N will be connected to positive potential, P will be connected to negative potential. I'll give as name VPC. Okay. Now similarly, emitter side I'll connect a resistor, then I'll connect like this and I'll give the name as VEE. This is RE. Okay. So if I am connecting 5 volt here, 7 volt here, then you can see this is collector base junction is reversed biased, and emitter base junction, you see here emitter base junction, P is connected to 7 volt, N is connected to 5 volt. So P side is higher potential, N side is lower potential. So this is emitter base junction is reversed biased. It is not visible here, but it will be forward bias the emitter base junction. Understood? Now we'll represent the current. So this is your IE, this current is outgoing IC, this current is outgoing IB. So output by input. What is my output current? What is my input current? Tell me. This is my output side, this is my input side. So what is my output current?
Sir, IE by IB.
IE by IB. Okay. So alpha is for common base, beta is for common emitter. So gamma as the current amplification factor for common collector configuration. So gamma equals to IE by IB. So if you cross multiply, you'll get IE equals to gamma IB. Okay. So from the first to last, like here, what I have explained, output in terms of input. See, for common base IC in terms of alpha IE, that means output in terms of some factor into input. Similarly, for common base, this is my output, this is my input. See, this is output, this is your input. So output in terms of input with some factor. Similarly, here gamma also, this is my output and this is my input. So output in terms of input I have expressed. Okay. Now if you want to find out output in terms of IB, that is also possible. So what we'll do, I equals to IC plus IB. Then in place of IC, you can replace alpha IE plus leakage current. Then you replace all these equation here in IE. Then you just solve it. So you will finally get I equals to 1 plus beta IB plus 1 plus beta into ICBO. Okay. So using all these equation, whatever I have explained here, that will be come in the exam as numerical. Next class, we'll discuss about alpha beta gamma relationship and some problem related to these equations. Okay, that will complete your syllabus for mid-sem. So tomorrow, Monday, we'll complete this one. Then Tuesday we'll revise. Okay. Wednesday, Wednesday we'll go for revision and transistor characteristic. Then we'll go for exam. I have uploaded assignment also. You have to complete within 1 week, and I think all of you have opened the classroom. We'll move to test. All of you open the classroom. Switch in your video. All of you switch in your video.
वीडियो क्यों ऑन करना है? क्या नशा किया है?
Arya, your mic.
686. You unmute. 668. 868. Aryak. 868. Aryak. Unmute yourself.
Sorry, sir. Sir.
No, you are attending class or you are enjoying at home. Huh?
Sorry, sir.
All of you switch on your video and open your classroom.
Excuse me, sir.
Yeah.
Sir, I have network issue in my area, so I won't be able to switch on my camera, and also we have physics quiz also, and I'm using mobile data due to that.
So exam will be only 5 to 10 minutes, so that will not consume more data. No? You have to switch off your video till the 50-minute time. No problem. Switch
Okay,
on.
sir, I'll try. Okay, sir.
Are you able to see the quiz? AC VB17 week Q2 I have given.
Sir, we can start.
No, wait. I'm not able to see anyone's video. That's why I'm waiting.
Sir, what is the code, sir?
First, you switch on your video. Okay, I'm posting the code. Time is 10 minutes. 10 questions are there. $7.53. It's 5:53. So 5:58. 6:03 will complete 10 minutes. Okay. So all of you check your chat box, copy and paste, and tell me whether it is opening or not.
Yes, sir.
Okay. So 6:03 is the cutoff time. 10 minutes.